Hi, good morning, everybody. Um, I think we are gonna wait just for a minute, just for one more minute to wait for everybody to log in, everybody that registered. In the meantime, um, my name is Michelle. Can you guys tell me if you can hear me and if you can see my screen? You can use the questions feature and go to webinar to let me know. I've already received a couple messages there, so you can just tell me if you can hear me and if you can see my screen. Great. And also while we wait, can you all tell me from where you're watching me today? Just so I know where everybody is. I always like to ask that. That is so nice. We have people from everywhere. We see Arizona, Boston, Croatia, Chile, Detroit, Toronto, more people from Canada, Oklahoma, Arizona, a lot of people from Canada, Brazil, Nashville, Moscow, St. Paul. Oh, that is so nice. From Poland too. Wow. What time is it in Poland right now? Well, I think we've waited long enough and I think we can start the webinar. Um, well, thank you all so much for being here today. Good morning for everybody that it's morning, or for everybody else that it isn't. Good afternoon. I see that it's 5 p.m. in Poland. Thank you. My name is Michelle Velis, and I'm a technical support representative here at Palisade Company. And today I'll be presenting an introduction to risk registers and cost estimation using AppRisk. Um, Before I start, I would like to ask everyone if you are a beginner, an intermediate, or advanced user of the software. And you can let me know using the questions feature like we've been doing so far. And while you do that, let me tell you a little bit more about Palisade. We are a global company founded in 1984. Our headquarters is in Ithaca, New York, and we have offices in Brazil, London, and Ecuador. And that's where I am. I'm in the Ecuador office. We are the developers of the leading risk analysis software in the market, AtRisk. AtRisk and all of our tools are used to improve your decision-making process, and all of them are Excel add-ins. If you're interested in knowing more about our software or all of our products, I invite you to visit our website, www.palisade.com, where you can find more information about all of our products and all of their features. While we're here, I will also like to tell you that if you have not installed the software yet, um, you can do it. You can install a 15-day trial by clicking on free trials and then filling out the form. You will then receive an email with a link to download the installer. Also, while we're here, I would like to show you our live webinars page and our on-demand webinars. You can find um, webinars that we've taught in the past, and the ones that we schedule every month are here in live webinars as well. Um, if you have already installed the software, then feel free to follow me during the webinar. Palisade also has different licensing options according to your needs, whether they're academic or commercial, as well as other services such as consulting, training, and custom development. If you need any information on any of these, please don't hesitate to contact us. Here is our contact information. And like I said, I'm a technical support representative. So if you have any questions after today's webinar that I haven't answered, please feel free to write me to support@palisade.com. I'll be more than glad to assist you. So before we started, I asked you um, if you were beginners, intermediates, or advanced users. Or if you've never seen the software, that's okay too. And I'm going through your answers right now. And most of you are beginners, intermediates, and a couple of advanced. Um, okay, so that's great. Thank you so much, everybody, for telling me. Um, so what does at-risk do? Well, at-risk analyzes risk in your Excel models using Monte Carlo simulation. And by doing this, it helps you discover not only what could happen, but also quantifies how likely something is to happen, which helps you to answer questions that we do every day in our work environment or um, at our classes, like what are the chances that we will make money on this venture? And what is the probability we will finish on time or within budget? As well as what is the range of capital reserves necessary to meet our goals. So that is our goal for today, and that is to learn some techniques that will help you in your cost estimation processes. Specifically today, we'll be talking about a little bit more about risk register. We had a cost estimation webinar, I think about a month or two, and we had a lot of questions about risk register after that. So we've decided to make this webinar a little bit more focused on risk register. And that is what we're going to do today. Let me Okay, so let's open up at risk. Like I said, our tools are risk add-ins, I'm sorry, Excel add-ins. So every time you launch it, Excel opens up automatically. Now the first thing that you see when you run one of our tools is the welcome screen. And this is great, and I always like to show it. And I see that a lot of you are beginners, so I'm going to show it again. And I'm sorry if you've been to any other of my past webinars. But one great thing to start learning about the software is our example models. So every time you run at risk, you will get the little welcome screen, and you can easily go to the example models here and also to our guided tour and quick starts. So just like to mention that, I'm going to show you another way to get to the example models later. And here is the at-risk ribbon in all of its glory. So another way that you can go to the example models is through the help menu and then example spreadsheets. A new window will open, and we have a list of our example models. These are divided by industry and also by the different features of the software, the ones that are usually used the most. So for now, let's go to a cost estimation model. This is a very simple cost estimation model. And it is important that we start there so that we can have a base to later go to risk register. All of our models have an explanation in the first sheet and then the model itself on the second one. Let me remove these graphs and boxes, and then we can focus on the model itself. Now, this is a very simple model, I know, but this will give you an idea of how the software works. In real life, you will probably have much, much larger models, but just keep in mind that the methodology is the same and how you use the software is fundamentally the same. So this is just to give you an idea of how to start using the software. And in this cost estimation, we have different cost elements such as land, building, IT, vehicles, marketing, etc. And we've also um, entered a base case here. And this is what we're used to, right? Having a static model with guesses of costs. And these numbers have been truncated just to make them easier on the eyes, but these are really millions. Um, so we've also summed them up and we have a total here. What we've also done here is we have added 3-point estimates to all of these cost elements here. We have added minimum, most likely, and maximum. And now people usually ask in webinars, where do we get this information from? And there were different techniques for getting this kind of information, like historical data, market analysis, experts' opinion, parametric methods, and others. So really, it depends on what you're trying to do. And usually people have this kind of information at their work. So you can kind of count on that. If not, you can always contact an expert and get this type of information. For cost estimation, our Palisade consultants recommend to use distributions such as PERT and triangular because they are 3-point estimate distributions. So that is what we've done here today too. Like I said, here's a PERT and it's assigned to all of our inputs here, and here's our output. But I think I'm going a little fast, and let me just show you first how to define a distribution, because really that is what at-risk does, right? Um, I like to give this example, and basically what at-risk does is like a virtual experiment, and we're repeating that experiment 100 or thousands of times. We're collecting the results data in each of their experiments and then organizing it so that we can later analyze the results and understand the behavior of um, that process or that system. And that is basically what Monte Carlo simulation does. You know that it is a mathematical technique. You know that it generates random variables from these probabilistic distributions, and it models the uncertainty of a certain system. So that's what it does. So to add a distribution to your model, what you have to do, why don't I delete these? You have to click on the cell you want to add it on and then click on define distributions. Um, I forgot to mention before that everything that I will use in this webinar, the recording, the slides, and all the models will be sent to you probably next week or the week after that. So even if you register but are not attending, we will be sending all of these to everyone that registered. So for some people that are asking that, so I just wanted to answer that right now. And also, if you have any questions while I'm talking, please feel free to send them my way. I will stop every now and then and answer all your questions, okay? So when you open when you click on define distribution, you will see all of the distributions available in at-risk. And I know this can be overwhelming for people that have not seen this before. We have many, many, many distributions, discrete and continuous here. And this is called a distribution palette. You can find them divided, like I said, by continuous and discrete. But if you are beginners, I recommend you to stick to the comment tab. It has distributions that most likely you are all familiar with, like normal distribution, binomial distribution, discrete, these probably you've seen before. So I recommend you to stick to that. And once you feel more comfortable, you can just go ahead and explore the software a little more. Another thing that I always like to say is that you can, there's a little help icon in all of the distributions. You can just click on that and you will see information about that distribution, how it's used, the parameters it needs, and formulas and more information about that. So that's a great way to learn. As well as there is always a help icon in all of the at-risk dialogues. So you can just click on that and find out what that dialogue is for. For now, I will select PERT and then click on Select Distribution. Okay. So you can either enter the parameters for the PERT distribution or for any of the distributions manually here, or you can use these buttons so that you can assign a reference, an Excel cell reference, which what I'm going this was it's what I'm going to do today. So I'm just going to click on that, and then I can click on each of my parameters. I click on this button and I go back to my define distributions dialog as I was before. Another thing is that if you hover on top of these, then you will get like a little floating label there that will tell you what that value is, what is looking for. So I have a question here, and it is, what is the difference between PERT and triangular? Well, there's a nice feature here, which is called Add Overlay. If I click on that, I get a little mini palette, and I can select another distribution that I would like to overlay, and I can just add it here. And it already picked up the same parameters that I had that I used before. And the difference really with PERT and triangular is that PERT is a little softer on these edges and it focuses more on the most likely or mean than the triangular does, where it actually focuses a little bit more here. Not like the PERT, where it's softer around this kind. So triangular has this little focus on tails where PERT doesn't. So I guess PERT can simulate reality a little bit better, but really it just depends on the kind of information you have, on the kind of data you have, and what you're trying to achieve. If I click on this X, it will delete these distribution, and I can just click OK, and it will add it to my model. Now, another great thing about AboutRISK is that it works on the Excel environment. And that takes a lot of learning there, just because you already know how Excel works, so that is great, and you can use Excel features as you would normally. And now that I've added my at-risk distribution here, I can just drag it, and I will add it to all of my inputs, cost elements that I have. Now what we've done here is sum up all of our sample cells using Excel's already existing sum feature. There we go. And here is the best part, I think. What we have to do here is add an output. An output is that cell that you want to keep track of, the one that you want to observe, the one that you need to know. AboutRISK helps you with a name, and it gives you an example here. You can edit it, or you can enter a completely different name. It looks to the left and up, and it gives you that. I'm just going to leave it at totals and click OK. Another thing that you're asking is why these go blue and this one turns red when I define my distributions and my output. And that is because I have color cells feature turned on. So it makes them, all of the inputs go blue, all of my outputs go red, and all of my functions, statistic functions, turn green. You can also change them. I mean, you can certainly change them, but this is just the default colors, and that's what I have right now. So what is really AboutRISK doing here, and why is it important? I mean, we already have these maximums here. Why cannot we just sum them and then say that this number is our budget? Well, reality is that the maximum is just saying that all of these cost elements will go wrong, and something bad will happen with all of them. So in reality, that really doesn't happen. So is it really smart to have that amount of money instead of having this amount of money? I guess not, right? So why don't we just run a simulation and see what information we can get from AboutRISK. Okay, so I'm going through your questions now, and most of these will be answered as we move along the webinar. So I think we can continue. And yes, if we have time, yes, we will be showing a correlation example. Okay. Some of you are saying that you cannot see the bottom of my screen. So can you just tell me if you can see my pointer right now? Okay, great. Okay, so I see that some of you cannot see my pointer. So let me just make this window not that big. How about that? Okay. So here is our results graph. And we have different features here in AboutRISK to study these. And these little lines, I'll call delimiters, and you can move them around in your graph, which is great so that you can know more. And another thing that you can do is instead of just moving them manually, you can enter number here, and it will move it for you specifically to where that is. Now, our cost base was 18 million, right? Now, if I move this delimiter all the way to the right, I see my probability here, and I have an 83.5% chance of actually exceeding that number. And now that doesn't sound so great, right? Maybe that wasn't the best way to get that number before. And what I can tell now is that I will probably spend a little more. So maybe I can focus now on this specific number, and I will feel more comfortable going to my manager, going to my boss, and saying what I found and what will be best for the budget of our project. Another thing that we can find in this window is our statistics. And we have very important information here, like the mean, the mode, percentiles, and more. And we can use percentiles to also calculate our contingency. So let me go back to my presentation here. And let's talk a little about contingency before I show you in this model how it's being calculated. So contingency is an amount added to an estimate to allow for items, conditions, or events for which the state, occurrence, or effect is uncertain, and that experience shows will likely result in aggregate and additional costs. Now, this is typically estimated using statistical analysis or judgment based on past assets or project experience. So there is an at-risk function, and you can find them all here under insert functions. But there is one called risk percentile. So if I get my 95th percentile from my output, I can just write risk percentile, put my output and the percentile that I want. And then if I subtract what I had in the base case, I get what my contingency budget is if I need a 95% confidence level on that. So that is another great thing that we can get from at risk. Okay, do you have any questions up to here before I go with risk register? Okay. Thank you all so much for your questions. I would really appreciate it if we can have a respectful tone in all of our questions. That would be very great. Thank you all for that. Um, so you would like me to tell you a little bit more about the output. And yes, of course, I can definitely do that before we move forward. And so what we've done here, we've added different distributions to our model, to our inputs here. We added risk PERT to all of them, which is a 3-point estimate distribution. And we calculated that using our minimum, most likely, and maximum Some of you are asking where we got that, and there are different methods to getting this kind of information. Experts' opinion is the most common one, but also we can get it from historical data, market studies, and more. So in this case, we already have it, and we use this information as parameters for our risk part. Then we sum them all up in cell J13, and we made this our output. The output is the cell that we want to monitor, the one that we want to know the information of. And what we do here, what AboutRISK does for us really is that it uses Monte Carlo simulation to generate random variables from these probability distributions, and it models risk or uncertainty of this specific model that we have. You know that risk can be defined as the difference, something that can happen that you had not foreseen. So this is what we're doing right now. Do you want me to explain more about how Monte Carlo simulations work? Well, we actually have a webinar on that, and I think this was our past webinar. It was an introduction to risk analysis. I recommend you to take a look at that. And let me write up your name, Abdullah, and I will send you an email later when we're done with that, with a link for you to download that so you can watch it, okay? All right. Okay. Now let's talk about risk registers. Let me close out of this model. Now that we're familiar with that, we're going to use it later. But let's close out of that for now. So a risk register are risk events that have a very low probability of happening, but a very, very high impact on the project if they do. So I'm talking about a strike, a non-feasible design, an environmental approval delay, maybe a resource scarcity, like the materials that we need are not available anymore, maybe a flooding or a fire or a merger and acquisition, or let's go really far with it and think of an executive being kidnapped. So those are kinds of events that have a very low probability of happening, but a very, very high impact when they do. Um, does at-risk handle both positive and negative risks, both threats and opportunities? Yes, it does. Let's open up a very simple risk register model. There we go. It's actually the one here. The one that I had in my screen now was a risk register that I added to the cost estimation model that we have before. So we're going to go to that in a little second. But first, let's talk just about risk register. So like I said, these are events that have very low chance of happening, but a very high impact when they're due. So that is exactly what we want to calculate. If it happens and what happens if they do happen. Okay, so here's a list of risks that we've already put out here. And now there is something that you must know before we continue, and that is that there are two types of risk registers, one that is single and one that is multiple. Um, a single is an event that will happen just one time in the life of your project, but a multiple one is one that can happen more than once in the life of your project, like what we have here, availability of labor or capacities and experience of subcontractors and suppliers. So those are things that can happen more than once in the life of your project, right? So there are different ways to calculate the occurrence of these, but for both, you need the probability or the frequency. For risk events of single type, you have to enter a percentage of how much that could is likely to happen, and that is the probability. And for a multiple, you have to enter a number, which is the frequency as well. Now, you calculate the occurrence of these happening in a different cell using one of at-risk's distributions called risk Bernoulli. Let me show that to you. And the parameter that is being used is that 2%. As for risk events of multiple type, you use another distribution called risk Poisson, which gets the mean from this value and tells you the occurrence of that risk event. Once you've modeled the occurrence, then you need to model the severity. For this, we've done exactly what we did in our past model, which is using a risk PERT to calculate how much that risk event happening is going to cost us. So an incomplete design will most likely cost these, but we can go up to 2,500. Sorry, 25,000. So we have added here 3-point estimates just like we did before, and we added a PERT distribution. Now we have our occurrence and our severity, which is how you calculate risk. You multiply occurrence by severity, so you multiply the occurrence by severity or the impact, and you get how much that is going to affect your project. So what we've done here is the simple product of these two, and that's what we added in this cell. So if this happens, it multiplies by this. If it doesn't happen, it doesn't multiply, so you don't get anything here. Now, there's a very cool feature in at-risk, and it's this dice button here. So if I turn it on and then click F9 on my keyboard, I pretty much just get an iteration, which is what it does when you start a simulation. It has different hundreds or thousands of iterations are run. So here I'm doing it one by one, and it is calculating the occurrence of these risk events and then multiplying them by the severity of what it would cost me. So like I said before, this is the simple product, and you can do these when you're doing when you're starting out with Risk Register. But we have another feature, or we have another um, yes, sorry, another function that you can use here also, and I'm going to show you that later. But for now, let's just do a simple product, and we sum them all of these up just like we did before, and then the sum of them is our output. Because of course, this is what we want to monitor, this is what we want to know, what would happen, right? We can now run another simulation and check our results. Another thing that I would like to show you about our results window is that you can also get a tornado graph from here. Before going to the tornado graph, let me show you also an S-curve, which is also accessible just from this window. If you click on the little tornado, then you will get your tornado graph. And here you see which of your inputs is affecting your output the most. So you can mitigate your model this way. Let's close out of this for now. And let's go back to the model we have and just take a look at what we've learned from this, but put it in action in the model we had before. Yes, I have some questions here. And yes, I am running another simulation for the risk register. And I can add that to my cost estimation model so that I can consider it in my costs. And you are saying that, yes, this copy will be available. I will send you all of the models that I used today. We will send them probably next week or the week after that, along with the video and the presentation. I don't have, this model is not available in our example models. This was done separately, but I will send them to you after that. So it's not possible for you to open them up now and follow me. Okay, so you're already familiar with this small cost estimation model. Let me run a small simulation and then go to browse results and explain why these numbers are different now. You can get to the browse results by clicking on your output and then clicking on browse results. So let's go back to our tornado again here. And this is what I was telling you about. Here you can see which of your inputs affect your output the most. And you can actually use this information to mitigate your model a little. And this is what we've done in this one. And now in this model, we changed these numbers a little. We changed them around, and it's a little closer to reality, let's say, now. So this is the same thing. We've added here, what I did was changing from risk per to risk triangular, just so that you can see a difference, and you can do that. You can certainly do that. PMI recommends PERT and triangular. Our consultants, like I said before, do as well. They recommend part a little more, but that's okay. And we've summed them up. And now here we have a very, very, very small risk register. And it's one that is very exaggerated. We have 3 risk registers here: an earthquake, a worker strike, and bad weather. We have sampled these just like I showed you before with a risk Poisson for those risk events that are multiple, and a risk Bernoulli for those that are of single type. I've removed the cell explaining which type these are. And we have calculated the severity as well, just like we did before. And this time using our risk triangular. But here I've actually used a risk compound now. And what a risk compound does is that instead of just multiplying this number and this number, this is a feature that at-risk has to calculate with occurrence and severity specifically. So it's very great and is most commonly used in risk registers. So I wanted to show that to you here. Now let's compare. Let me change this and make a comparison. That I think will be better visually now that I see it. Okay, here's our total of what we had before, and let's enter one that will be considering our risk register. And of course, let's make this an output as well. And we can now run a simulation and compare them. I can just click on browse results. Let's go back to our histogram. I can make this a little bit smaller. And you see how this window is attached to this cell as a little arrow there. I can actually click on this button and it will convert it to a floating window. And I can open up another browse results window next to that, like this, and compare. Or I could directly click on Add Overlay, click on my other output, and overlay them so that I can compare. I can also compare my statistics. And so this is another thing that we have to consider with cost estimation, and that is the risk registers. It is very, very important to consider them, and they are almost never considered. But another thing that you should consider is also correlation, and I had a couple questions about that. So why don't we talk about that a little? And We've been working up so far with the assumption that our cost elements are not related to each other. And really, we shouldn't say that, because there is a chance that two or more of them are actually have a relationship with one another. So what if they're not really independent variables? And one thing that we must understand first is what is correlation. And a correlation is when two or more input distributions are related. And the correlation coefficient is a statistic that measures that relationship. So it measures the degree to which those two or more variables move in a linear relation to each other. Now, the correlation coefficient is represented by a value between -1 and 1. And I am sure that most of you already know this, but we had a lot of questions about this in a past webinar. So that's why I'm explaining specifically what correlation is. So let's say that two or more of our cost elements are related, that they have a relationship to a relationship. And what about buildings and raw materials? If raw materials go scarce, or there are no or there's not certain material that we need for our building, then probably our building will cost more. I don't know. Let's think about that. What we can do here is add a correlation matrix to these two and study that, and maybe see if actually that relation is important or not. To do that, what we do is select those two cells and then click on Define Correlations and then Define Correlation Matrix. And we get a little matrix here. And it's like a mirror, right? So J4 and J4, it's the same, so it's a 1. J5 and J5 are the same, so it's a 1. But if I change a number here, it would automatically change it here as well. So I can then just enter 0.2, and it will change it here. Another great thing is that you can actually change this little box, this little matrix. Instead of having numbers, you can show a scatter plot, which is a little more visibly appealing, and it helps understand the relationship between these two variables a little bit more. When I was just beginning to use the software, this actually helped me a lot to visually understand how the relationship was. So I like to show it because personally it helped me. Let's pretend that these two are very, very highly correlated, possibly positively correlated. What we have to do, and I just enter a 0.7 there. Remember that it has to go from -1 to 1. And I'm going to enter a name. And then I have to select a location where I want to add my matrix. I'm going to add it here. Click OK to that. And then I can just click OK to everything, and it will add my correlation to my model. So we can now run another simulation and check if this affects our total cost or not. We are really running out of time, and I would like to answer your questions. So can you send me every question that you have right now? I'm going to go all the way back and check questions that you have before. Oh, yes, I keep seeing this question about Latin hypercube, but I don't think we can go through that today. We do have a couple articles on that, and I can send them to you, Alexander. Let me write down your name, and I'm going to send them to you later. Oh, okay. I can tell you again how to do the overlay. There are different ways to do the overlay. So let me show you one now. You can just go to browse results. This is what I did before. And then I clicked on add overlay. It's this little button here that has like a small overlay. I click on that and then I select the cell I want to overlay. Here, click OK, and it does my overlay for me. Another way that I can do that is through model window. If I go to my outputs, I'm sorry, I wanted to show you also how to navigate through your model. So you can navigate through your model just by clicking here, and it goes to that output specifically. This is a very small model, but when you have larger models, this is very helpful. And another thing that you can do is actually your inputs. You can just click and drag them, and you will get the graph for that. And you can use the same technique to overlay them like that. Okay, so I have some more questions here. Okay, yes, we do have, I have a question here that it says, why not let the model pick the best fit distributions and best fit simulations instead of just PERT and triangular? Is the model picking the best simulation model? Well, this model specifically is a cost estimation model. If you have different models or similar models or cost estimation models also, and you have all the information, you can certainly use one of the at-risk features called distribution fitting, where it will feed a distribution to your data. And that is a very great way to, if you're not familiar with all of the distributions, you can certainly use the distribution fitting feature, and it will help you find the distribution that fits best to your data. However, since this is a cost estimation model, really it is recommended, and I really honestly recommend you also to look up the field you work in, the industry you are in, because there is already a ton of information out there of which distributions are best depending on the industry. But for cost estimation, we recommend to use triangular or PERT. Okay, some of you are telling me, sorry, a couple of you are saying that you need to go. Thank you so much um, for your messages, for your kind words. I'm very grateful. And yes, the webinar will be available to you later. We will send them to you. Like I said, we'll send it to you in a couple of weeks. I'm sorry, next week or the week after that, along with the models that I am using here today and the slides. Thank you so much, everybody, for being here today. Thank you all for all your nice comments. I appreciate them a lot. I hope that I've answered a lot or most of your questions. If you have any questions, please just don't hesitate. You can write me to support@palisade.com. I will be more than glad to assist you. And have a great weekend as well. A very, very nice day to all of you. And yes, we will continue sending you the updates for upcoming webinars. Have a nice weekend. Thank you, everybody.